Hello and welcome to this first lesson in a lot of lessons that I will be taking in some time. Today we are going to talk about what is work. Work exactly होता क्या है ये जानने की कोशिश कर रहे हैं आज हम. आपको अगर दिख रहा होगा नीचे एक वीडियो में, इफ़ यू सी द वीडियो डाउन बिलो, जेम्स फ्रैंको को एक मुक्का पड़ रहा है. जेम्स फ्रैंको इज बीइंग गेटिंग हिट बाय अ बॉक्सर. So what exactly does this signify with respect to work? You can say यहाँ पे जब एक हाथ आता है इस तरीके से और उसके मुंह पे लगता है तो there is a force applied by the boxer and the displacement of the face will decide कितना work हुआ. Want to know more about it? Let's go there. Now the first thing that I would like to say is that work is a word that is used in a lot of places, right? Everybody does work, right? If you talk about a student, the student will say that my work is homework, right? I would be probably doing it on a notebook with my pencil or a pen. Let's talk about a fitness enthusiast. They will say that, you know what, this treadmill where I will run, that is my work. In fact, they might work out with some weights as well, right? Anyways, we talk about a taxi driver and we can say that over here doing their job is getting the work done, right? If your dad goes to job, they say मैं काम पे जा रहा हूँ, right? They are trying to go to work. But what does this work mean? This work means something different in everybody's context. So this work actually means a little different in context of physics as well. अब फिजिक्स में अगर आपको वर्क की बात करनी है तो देयर आर थिंग्स दैट यू मस्ट नो, राइट? व्हाट शुड यू नो? लेट मी टेल यू. इफ यू टॉक अबाउट वर्क, this is a chapter that comes in your life after you have studied about kinematics and dynamics. They are being written in pink over here and in blue over here, right? So what I will say is that you must have heard a lot of terms in kinematics. Let us say you would have heard about displacement in S, velocity in u or v, acceleration in a, time in t, right? All these things you have heard. You talk about dynamics, you must have heard about force, you must have heard about torque, generally t, or some people write it as tau. So the point is, what I'm trying to say is that these two chapters you have studied earlier. Now what is the relation with work? The relation with work is very simple. You will say that this two topics combined. If you talk about kinematics, if you talk about dynamics, you combine both of them and you get work. If you talk about it with respect to linear terms, you would be requiring force that we saw over here in dynamics and displacement that we saw over here in kinematics. But if you know, in kinematics it's not only linear, it might be angular as well. So with respect to angular kinematics, you have angular displacement in theta, you have angular velocity in omega, angular acceleration in alpha, right? Similarly, you have time. You can say omega initial and omega final if you want to replace u and v. But my point over here is that if you talk about work with respect to angle, there is angular work also given for you, and for that you would be requiring the terms of torque over here and angular displacement that is over here. So let us talk more about it, right? So now what do we have? We have three very important questions for you. How would you start to define work? Right now all you know is from where does it come and what is the basic. The basic is something that you have learned in kinematics and in dynamics. Now if you talk about the basic three questions, I would say first thing, please tell me what is work. The second thing, when will this work be coming? When can I say that work has happened? When should I even talk about work? And the third question would be, how do I calculate it? Is there something through which I can calculate? So these three should be your basic questions. What I have seen in maximum students, they say कि सर वर्क कैलकुलेट करना बता दो, क्या होता है इस सब से हमें अंतर नहीं पड़ता. You might get your questions correct, but the theoretical understanding of the topic remains unclear, and that is something which I would say, if you want to learn something, put in everything. तो चलिए स्टार्ट करते हैं फर्स्ट क्वेश्चन से, व्हाट इज वर्क। तो इफ आई टॉक अबाउट व्हाट इज वर्क, यू मस्ट हैव नोन अबाउट एनर्जी। एनर्जी आपके आसपास हर तरीके से रहती है, राइट। तो वर्क इज अ वे सच दैट यू कैन मेजर द अमाउंट ऑफ एनर्जी जो ट्रांसफर हो रही है बॉडी के अंदर या बॉडी से बाहर, right? The amount of energy that is being transferred in the object or out of the object, this is what work is. All right, so this is the basic definition कि अगर मैंने किसी चीज़ से एनर्जी ले ली तो I have taken up work from them, and if I have given that energy तो I've done some work on them. Okay, so this is going to be the basic understanding with respect to physics. Later on when we will deal with numericals, we'll deal with problems, we are going to get to know about it much more. The next question, second question, which I would like to answer is that when will work be there? So if you see, I hope you can tell that work would be there if there is any force or if there is any torque. In the absence of force, in the absence of torque, you cannot say any work is there. So you always talk about work done by a force, work done by a torque. So these two things are going to be absolutely necessary. And the final question that I would like to answer is how to calculate work, right? So this you must have heard. The most common thing that everybody hears is W equal to F into S. Everybody knows this, almost everybody. Whenever I ask them what is work, they say F into S, right? Not knowing how it should be answered. So F into S is correct to a certain extent, and that extent I would like to tell that whenever you have to talk with respect to calculation of work, it could be either in the form of force or it could be in the form of torque. So I would say that if you want to talk with respect to force, you will say it is the product of force and displacement, but this displacement must be along the line of application of force. Very important line, that whenever displacement along the line of application of force is there, this is 100% correct, otherwise it is not correct. Okay, similarly you can talk about torque, that whenever you have product of torque and angular displacement, this time this angular displacement must be along the direction of torque, and then you can say W is T into theta or tau into theta. I hope that all of this is clear to you. If you have any problems coming up anywhere, please make sure with the time stamp you write down a comment below so that I can answer it accordingly. Okay, let's move on to the units of work. So there are some 2 units of work that I would like you to remember because these are the most commonly used units, and that happen to be erg and joule. So the SI unit of work, the thing in which it would be calculated, you know that distance is calculated in meters, time is calculated in seconds, force is calculated in Newton. Similarly, work is calculated in joules. So if this is SI unit, we call this unit as erg, and if this is a SI unit, we call it joule. What is the relation between both of them? 1 joule equals 10 to the power 7 erg. This is something that I want you to do as a homework. You can try doing it on your own. I hope you can easily convert the SI unit to CGS unit, right? Just write down 1 joule as 1 Newton into 1 meter, that is force into displacement. You can put down Newton in the form of dyne, you can put down meter in the form of centimeter, and the next step already gives you the relation, right? Okay, let's talk about final things before we proceed to do some questions. The types of forces in work, there are some 2 types of force that can come. If you talk about work, there could be either a constant force or there could be a variable force. Now what is the difference between both of them? I would like to explain it to you with the help of a diagram so that it becomes much easier to remember. If I talk about constant force, what I see is that I have some 4 blocks. No, एक ही block है. One block at different times is given to you. You can see at time t equal to 0 seconds, t equal to 5 seconds, t equal to 10 seconds and t equal to 15 seconds. At all the times, the force magnitude is same, that is 10 newtons, and its direction is always towards right. So a force with same magnitude and same direction happens to be a constant force. If I want work done in this case, I will say my work is done due to a constant force. Now, how could it be a variable force? It could be variable as well. That is no problem, right? If you talk about variable force, you will say that either the magnitude or the direction or both can change. I have shown it to you very specifically from 0 to 15 seconds. If you can see from 0 to 5 seconds, the direction is same but the magnitude has changed. There is a change in magnitude. From 5 to 10, you will see that the direction has changed but the magnitude is same, that is 5 newtons. So this is changing in direction. And if you talk about the final case, from 10 to 15, this direction is changed and this magnitude is changed, so both is changed. So if you talk about the bottom case, this is the case where you will say variable force must be considered whenever work is to be calculated, right? I hope this is done. So here's a simple little question for you, that if we have a constant force, I hope this is pretty much explanatory over here. If we take a constant force and you are given the force as 10 Newton, the displacement as 10 meter, can you tell me what is the work done? Now a lot of people would try to answer this and would come up with the answer 10 into 10, that is 100. But let me tell you guys, that is incorrect. The answer is it cannot be calculated. Why? I'll tell you why. You try to answer this question now. This is just a little bit different. If you see, the force is again given as 10 Newton, but the displacement in the direction of force is given as 10 meter. So this is the difference. And this actually helps us know that now we can write down work equal to F into S, and that would easily come out to be 100 Newton meter or 100 joules, right? This is how we will tell the difference. This is a very basic point that students generally miss. So I want you to remember this. Now, if the same question is put up in a different way, now it is a tough question. Why? Because now you'll have to think a little. The force is 10 Newton. The displacement is 10 meters again. Now it is asking, can we comment on the work done here? Can you comment anything on the work done here? My answer is something that I would like to explain to you in the upcoming slides, and that is this. We can say it is anything in between minus Fs to plus Fs. You will say, sir, I did not understand anything, right? Why did you not understand? Because you need some more wisdom in work, right? What is the more wisdom in work? This is where your chapter number 1 would be recalled as well. I hope everybody remembers chapter number 1 we study in physics is vectors, right? We must know vectors if we have to understand kinematics, if we have to understand dynamics. So obviously, if work is a combination of both of them, you should know vectors by default. So what we say is work done is a scalar quantity. Work done is a scalar quantity and it is F dot S. It is dot product. You can say this is scalar or scalar product of F and S. If you see, F dot S would be written as mod F mod S cos theta. What is F, S and theta here? F is the force applied. S is the displacement of the point of application of force. Again, a very important thing that you have to see that point exactly which is to move. If you see any other point, you will get incorrect results. So please make sure whenever you have to see, you see that point only which is moving. जहाँ पे force लगी उस point को ही देखना है और किसी point को मत, इतनी बड़ी body थी, force मान लो यहाँ पे कहीं लगी, तो you just consider this point कि ये कितना move किया, that is all you want. इतने पूरे हाथ में यहाँ पे अगर force लगती है तो you just have to consider this point. If यहाँ force लगती है this point, That depends which point you are talking, and that is one thing you must remember at all times. What is theta? Theta is simply the angle between the vectors f and s, basic definition, right? So now I would like to show you some cases where I can talk about different types of work. If you talk about this first case, you will see that if I say my yellow vector is f everywhere, my yellow vector is f everywhere, and my purple vector is s everywhere. In the first case, the angle made by theta between f and s happens to be acute. We will say that this is the case where cos theta will be positive, so work done will turn out to be positive. If you talk about the second case, I am talking about this case now. You will see that the angle over here is given as 90 degree. That means cos 90 would become 0. If it would become 0, work done turns out to be 0 itself. If you talk about the third case, the angle between f and s is obtuse. That means cos theta will be negative in the second quadrant. That means that work done over here will be negative, right? And if you talk about the final two cases where we say that we have collinear vectors. What do you mean by collinear? Means in the same line. So if f and s are along the same line such that the angle between them is 0 degree, your work done would be f s cos 0. Cos 0 is 1, so work done would be positive of fs. That is the maximum work done that you can get with a certain f and a certain s. If you talk about the other case where angle is 180 degree, just opposite to each other, again collinear, in same line. One was like this, in the same line, one is like this, just opposite. So you will say in this case cos 180 would be minus 1, so fs cos 180 would give you work done as minus fs. So this is the case I was talking about, that if I have a certain force, say 10 Newton, a certain displacement as 10 meter, can I comment on work done? Yes, it could be between minus fs to plus fs. I hope this wisdom in work, the scalar product of work, you understood, and hopefully you got my point how you can tell different works for a certain force, certain displacement without any angle given between them. So now I have summarized this for you. I hope that you can understand this pretty easily. If this is the formula, work done equal to f dot s mod f mod s cos theta. If we have an acute angle, we get positive work. If we have 90 degree angle, we get 0 work. If we have obtuse angle between f and s, we get negative work. And if collinear vectors are there, f and s, if it is in the same direction, we will get plus fs. If it is in the opposite direction, it is minus f into s. Right. So now the lesson is officially over. You have some quiz time. Please make sure you attempt this quiz and write down in the comments what you think are the answers. I will reply. Don't worry about that. But if you had any doubts as well, it would be great to have it, because that is what as a teacher I yearn for. First question, you are given a force, you are given a displacement, you are being asked the work done. You can write down your answer as 1A, 1B, 1C, 1D, whatever you feel is correct. Similarly, here is the second question. I think you can see there is a certain change. This is the force, this is the displacement. If I talk about the third question, I hope you can see a certain change over here as well. You can write down its options again in the comment below. It would be great if you write down all 5 questions at once. Question number 4, you have this sort of a setup, but now the options have changed. And similarly, you have a 5th question that has a certain different diagram, the options remaining the same. So it would be great if you can write down it in the comments. The next class, we would be doing a lot more problems. We would be considering the work done by a variable force as well. That is the next in line. Hopefully, you will be able to understand that with me as well. Thanks a ton, guys. See you later in the next session.